In this lesson, I'm going to talk about the persistence layer. It has many other names as well, like the data access layer or the DAL or the data logic layer. I like the term persistence layer, but if I happen to use one of these other terms, forgive me in advance. I'm really talking about the exact same thing here, okay? So the role of the persistence layer is to provide a gateway to the underlying data storage that's utilized in the application. While we typically think of this in terms of a relational database management system like SQL Server, that's not always the case. Ideally, any public interfaces of methods that are exposed in the persistence layer provide no hint whatsoever as to whether the underlying data storage mechanism is a relational database management system, a flat file, a NoSQL database, a cloud database like SQL Azure or blobs or queues or anything like that, nor does it give a hint as to the vendor or the database access technology. All right, that should all be encapsulated inside the layer and should not leak out. So let me do this as we're getting started here. Make an observation that tripped me up for years. Maybe I can spare you some confusion here. When you see a layered architectural diagram like this, if you're like me, you think in terms of dependency. After all, the presentation layer at the top clearly depends on the lower layer below it, the domain layer, for example, to get its data so that it can display something on the screen. And then also when it gathers data from the user, it's going to ultimately get it to the domain layer so that it can act on it and so on. So we would expect the code in the presentation layer calls methods in the domain layer, which is partially true. We're going to learn how it really works whenever we talk about application services layer in the next lesson. But we see a dependency here. The presentation layer depends on the domain layer below it. But we wouldn't expect the domain layer to even make calls up into the presentation layer. So this is a one-way relationship, and it makes it easy to replace the presentation layer with a different implementation. Say we move from an ASP.NET Web Forms application and we want to replace it with ASP.NET MVC. We can still use the underlying domain layer because we're making calls into it. The dependencies point from the presentation layer to the domain layer. So we know that the domain layer only knows how to act on the data to perform calculations, move workflows forward, and so on. It must depend on the persistence layer for these operations, right? But if that's the case, it presents a problem. If the domain layer specifically references the persistence layer, maybe even in the Visual Studio project it has a reference to the persistence layer project, well then aren't the two tightly coupled together? Doesn't the domain layer now have a dependency on the underlying persistence layer, and doesn't it make it difficult then to change out the persistence layer in the future? Well, yes. The solution to this is a principle called inversion of control, and it's implemented in a pattern that we know as the dependency injection pattern. Essentially, this is a matter of who creates instances of objects in the other layer. If the domain layer creates instances of classes in the persistence layer, then we've tightly coupled the two together. What we want to do is invert the control, invert the direction of the dependencies from the domain down to the persistence, and we want to change it so that the persistence is pointing to the domain layer. So to accomplish this, remember that saying I used earlier in this series, all problems in object-oriented programming can be solved with another layer of indirection. In this case, we insert another layer. It's a tiny layer in the form of C# interfaces, and the interfaces become contracts. The domain model says, hey, I'm willing to work with any number of implementations of persistence layer classes, but to work with me, the domain layer, you have to implement the terms and the conditions of my contract as laid out in this interface. All right? So now that you support these methods that are in my interface, and that would include the method names, the input parameters, the return values, the return types, we can work together. So then what we do is we rely on a third-party layer at runtime, or a third-party component at runtime, to pass in instances of a particular implementation of the persistence classes. We pass them into the domain layer classes. The domain layer classes will call methods that it knows that it exists because it defined them in its interfaces. It relies on the fact that the persistence classes have implemented these methods with the particular input parameters and return types because it's abiding by the rules of the contract defined in the C# interface. Now, this third-party software, it's called a dependency injection container, or a DI container. There's a lot of them available. Most of them are free, open source. They can be configured to pass in concrete implementations in the persistence layer, each time the domain layer needs an implementation of a given class. So I realize that you're probably going to need to see this in action, but this is what we're aiming for, to invert the dependencies away from the domain model. In other words, we want the presentation and the persistence layers to depend on the domain layer, not the other way around. All right? I don't expect you to get this the first time through. It took me a bunch of times of staring at this till I really understood it. I'm going to create an example in the second part of this series that'll give you something concrete to really sink your teeth into and to practice. And honestly, you should become very familiar with this technique. You'll see it all over the place, and it really will begin to define those people who really know how to develop software and those who don't. Okay. So to recap, the diagram you see in front of you is deceptive. The domain model doesn't depend directly on the persistence layer. Instead, it relies on the fact that the persistence layer implements the contract that the domain model has set forth. It can work with any persistence layer that implements the contract. Doing so keeps our application decoupled, keeps it technology agnostic, and more impervious to the impact of change. So our aim is to inject classes of the persistence layer into the domain layer and let the methods in the domain layer request the data it needs or request some operation on the data that will ultimately be performed then by the persistence layer. It doesn't care how the persistence layer gets its information. It only cares that it receives its data according to the interfaces that it's defined, including the method names, input parameter types, and return types. Again, I'm going to demonstrate how this injection, or more formally, how this dependency injection works in an upcoming lesson. It's one of the most important patterns that you're going to learn about. It'll help you keep your layers as well as individual classes decoupled from each other. The persistence layer, which is what we want to focus on now, it encapsulates the logic required to retrieve the requested data or change the data as requested, whether that's an addition, an update, or deletion to the underlying data store. The methods in the domain layer should allow data to be sent in, and return data should be passed out depending on the type of operation. And so there's 4 types of data that it should work with. First of all, it could be just simple types like ints and strings, receiving as input parameters and returning as return types. Or more likely, it'll be POCO objects. POCO stands for plain old CLR objects. These are just C# classes with public properties. Or it could be generic collections of POCO objects. So it could be a list of orders or a list of products, for example. Or it could be entire object graphs. So this would be lists of orders, each order containing a list of order details, each order detail containing an association with one product object instance. Okay, so that would be called a graph of objects, where we're talking about relationships and hierarchies of objects. Okay, notice in all of these cases, what's not being sent between the layers is anything specific to a particular data access technology. So there's no ADO.NET datasets and no entity framework entities being passed from the persistence layer to the domain layer. All right, no, native types or collections of plain old CLR objects. That's the only thing that we're passing. And since we may be working with relational database management systems to retrieve data, but returning object-oriented graphs to the domain layer or the application services layer, most of the effort that we're going to undertake in the persistence layer is in mapping relational data to object instances. So why do you have to do this mapping between relational data to object instances? Fundamentally, it's what's called an impedance mismatch. It's an engineering term, but it describes how there's a difference fundamentally between how designers design relational databases using COD's normalization rules, okay, and how you understand and design objects in object-oriented analysis, design, and programming, and how it teaches you to look at the world and design classes. Now, due to this mismatch in the styles and the tools that support these styles, developers have been struggling for years to create a silver bullet technology that magically maps relational databases to object-oriented classes, instances of classes, objects. These technologies that have been created are called object relational mappers. This has been the source of much consternation for developers over the years, and Microsoft, third-party tools, and individual developers have struggled to automate this. So currently, as I record this video, Microsoft offers the Entity Framework. It's a part of the ADO.NET API that most developers rely on to perform this mapping. And there's also some third-party and open source alternatives, the most popular of which is NHibernate, which is a port of Hibernate, which was originally created on the Java platform. If you come from a Java background, you're familiar with Hibernate, then you're going to gravitate towards using NHibernate on the .NET platform probably. Otherwise, I generally recommend that .NET developers only consider the Entity Framework at this point. But just because you want to use the Entity Framework doesn't mean all of your work is done. We're going to talk about challenges when using the Entity Framework when we talk about passing data between layers in an upcoming lesson. Remember, we don't want to pass anything that would indicate a specific type of technology that we're utilizing in the persistence layer. That would be a leaky abstraction. We'd be leaking out details about the implementation, saying, hey, we use the Entity Framework. We want to avoid that. And there's ways to do it, fortunately, with the Entity Framework to avoid that. But what I want to do for now is stay at a high level and just address some of those implementation details a little bit later on. All right, so we just finished saying that the main responsibility of the persistence layer is to perform data operations like create, read, update, and delete on the underlying data storage, whatever that is. The persistence layer should also be concerned with doing its part to maintain the integrity of the data. So in some cases, like in a relational database management system, there's built-in functionality to maintain relationships between various tables in the database. It helps to also handle concurrency issues. It allows for transactions to make sure the data remains with a high degree of integrity, even if something fails in a long update, and so on. These need to be enhanced and utilized by the persistence layer to meet any non-functional requirements of the system that those who are going to maintain it, like DBAs and so forth, might add to the requirements. Also, depending on which technologies are being utilized, there might be a lot of other stuff going on in the persistence layer, stuff specific to the given technologies that have been chosen. That might include things like managing the number of connections that the application makes to a database server. It might include transactional support, like we said a moment ago. And of course, it might involve security. And so, there's always these overlapping concerns between layers, and this is most obvious and pronounced in the tension between the domain and the persistence layers with regards to security. Who should be delegated the responsibility of securing the data? Well, when you design the application, you have to decide which layer should be delegated the responsibility of authorizing the user to access data or perform certain operations on the data. Now, admittedly, there's built-in functionality in most RDBMS systems, relational database management systems like SQL Server, for this very purpose. But the other option is to handle this in the domain layer. Whatever you choose will impact what's passed back and forth between these two layers. It'll impact the interfaces between the domain layer and the persistence layer. Most notably, are you going to be passing in an object that contains the credentials of the current user to the persistence layer every time that you want to perform any operation? So DBAs, database administrators, they probably are going to prefer to keep these sorts of things as close to the data as possible. And developers generally prefer to keep these sorts of things in the domain layer. Now, I understand the perspective of database administrators. I really do. It's their job to worry about the security and the integrity of the data, and if they don't lock the data down, it's their next in line, so they want to take control of managing security in the application. Nonetheless, as a developer, I want to encourage you to think of the domain layer as the main organizing principle of the application. The domain model is a model of the business. Its rules, its calculations, its processes, and yes, even its security, who gets to see or operate on the data. That really is the domain of the business problem, the domain of the domain layer. Since the domain layer is the model of the business, the persistence layer merely hangs off of it as an implementation detail. Remember, that's what we were talking about changing the direction of the dependencies. The implications of security stretch beyond what a given user has access to. It's a core concern, and it should be addressed in the part of the application where all core concerns are addressed, in the domain layer. Furthermore, we already said that the presentation layer could change. Maybe today it's a WPF application. Maybe tomorrow it's an ASP.NET application. Same thing is true with the persistence layer. Maybe today it's SQL Server, but what happens when your organization wants to package this application and sell it to other organizations? Perhaps they use Oracle or Windows Azure or something of the sort. But the way you implemented security now is tightly coupled to SQL Server's roles. What do you do now? Ouch. Now you got to go and implement the security model in a second and subsequent vendor-specific tool. I don't think that's a good decision. I don't think it gives you the most opportunities long term, and it doesn't avoid the most pain when it comes to change that could happen within an organization. So in that light, delegating the sole responsibility of security to the persistence layer and its underlying technology has a pungent smell to me, and I would try to avoid it if I could, or at least I would think long and hard before capitulating to the DBAs automatically. I'd ask some pretty pointed questions about the long-term viability of the project if the underlying data structure were to change, and what the company's willingness to pay for redevelopment of the entire application would be if that decision were made at some point in the future. And so we talked about overlapping concerns of security. There are other overlapping concerns. Validation of the data. Who should be given the responsibility of validating the data? Well, frankly, this one's a little bit easier. Validation should be performed on each layer. Simple validation logic on the persistence layer, and complex validation logic in the domain layer, at least in my opinion. So what exactly do you implement in the persistence layer? Well, when I think about a persistence layer today, I have a pretty narrow definition in my mind. Today I'm using the entity framework to generate an entity model, and I can do that in one of a number of different ways using each of their approaches. If I'm using an existing database, I'm going to use a database first approach and let it take its first crack at generating the entity model. If I'm working on a greenfield application, and if the DBAs allow me to do this, then I might use a code first model where I design my classes first and let it generate out the database from there. Now, rarely do I use the third approach, which is the model first, where I sit down with a diagram and model everything out. But I suppose if I felt compelled to, I could do that too. But no matter what, whichever approach I take, at some point I have an entity model, which is an object-oriented representation of the relational database or some data store. And it provides all the mapping between the underlying data store and the objects. So I can think in terms of objects as a software developer, but be working with relational database management systems without having to really do that mapping in my own mind. All right. And so then I merely query the model or command that model to add, update, or delete entities. And I usually use link to entities or use the various methods that are available to me for each of the entities to add additional new items, delete items, and so forth. And so to do that, I rely on all the generated plumbing code that was generated for me by the Entity Framework to take care of the dirty work of actually writing the T-SQL code, managing connections to the database, handling basic validation, throwing exceptions when things don't look quite right, and so on. So I generally just express my intent to the Entity Framework through the API that's generated specifically for my entity model, and then I rely on it to handle all the details for me. In the case of a query, my goal is to convert that query into either an object, a generic collection of objects like a list of orders, or an entire object graph like a list of orders that contains a list of order details, which contains, for example, a relationship to an individual product. And then I would return that up to the domain layer. Okay. So rarely do I have a need that's so advanced that I need to get in and tinker with how the Entity Framework does its job. I trust hundreds of developers at Microsoft more than I trust myself. Occasionally you meet up with somebody who thinks Microsoft doesn't know what the heck they're doing and they haven't accounted for some edge case. But more often than not, Microsoft's ADO.NET team has given this a lot of thought, more thought than I ever could. So I dive deeper into learning more about the Entity Framework before I get the urge to just go out, jump out, circumvent what they've done, and build a custom solution for a particular need. All right, so there's a lot more that I could say about this, but I would recap everything that we talked about in this lesson with regards to a persistence layer in a number of ways. First of all, we talked about what the persistence layer is and what it does. Basically, it's a set of methods that abide by a contract that's defined by the domain layer so that the persistence layer classes can be injected into the domain layer at runtime using dependency injection. This keeps the dependencies pointed away from the domain layer and keeps our application decoupled from specific data storage or specific data access technologies, and that allows us to remain flexible. Then I rely on the Entity Framework inside of the persistence layer to generate the classes I'll need to retrieve entities from the data store and commit new and updated entities back into the data store. Then I'll be mapping those to a data transfer object, so either a POCO object, a generic list of POCOs, or an entire object graph consisting of lists or collections of POCOs consisting of collections of POCOs, and so on. Data transfer objects. I'll talk about data transfer objects in another lesson, but we already said that we basically just want to either pass from the persistence layer into the domain layer simple types, POCOs, generic collections of POCOs, or entire object graphs made up of POCOs, and that's basically what we're talking about here. And then the third thing is, for the most part, I'm going to rely on the Entity Framework to handle just about all the issues I'm likely to encounter. I'll utilize its validation functionality to validate the entity model prior to submitting it to the underlying data store. I'll rely on it to manage the transactions. I'll rely on it to create and optimize the queries that I need to perform to retrieve data back, and so on. And then fourth, ultimately, the fact that I'm using the Entity Framework or a specific data storage technology should be hidden. It should be encapsulated behind well-defined interfaces. In other words, the rest of the application should have no clue how I'm getting or handling data or where or how it's stored. This gives me the ultimate flexibility to change any part of the data access functionality without impacting the rest of the application's layers. Okay, so in the next lesson, what we're going to do is talk about the application services layer, which we already said was an orchestration layer. It's going to orchestrate the activities of the domain and persistence layer and provide a friendly way for the presentation layer to call into our domain layer. So we're adding that sub layer in that Microsoft's application architecture called the application facade. We'll talk about all that in the next lesson. See you there. Thank you.